Hey guys, welcome to the first part of 312. 312 is a big one. There's a lot of stuff that's going to be going on in here. So just make sure this is one that you really got to make sure that you understand as we move through this. All right, so these identities are ones that we talked about last time. So just look over them, make sure that you know those reciprocals and quotients. Then these Pythagorean identities are going to be very, very important. Now, what I usually tell people is just memorize this one right here. This one will be used all the time. So it will be something that you need to know absolutely. And I'm going to show you how to get the other two from that first one. So sine squared of x plus cosine squared of x equals 1. So if I were to write this out, if I know that one, I can get the other ones. So think about if I were to divide everything by sine squared of x. Each part gets divided. Sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared. And then 1 over sine squared is cosecant squared of x. Remember, 1 over sine is cosecant. So this is actually number 3. Okay, we can do the same thing by maybe you can think about, well, what if I just divided by cosine squared of x? Okay, sine over cosine we know is tangent squared because they're both squared. Cosine over cosine is 1, and then 1 over cosine is secant squared. And there's our third one. So it is, if you can memorize the first one, you do need to have that memorized. It should come pretty easily off the top of your head. Then you can get the others. All right, even odd identities, you won't see them a lot, but the only ones that are even, remember our definition of an even function is f of negative x is equal to f of x. It's symmetric about the y-axis, are cosine and secant. All of the other ones, if you take a negative values, then you'll get the opposite. So for example, cosine of pi over 4 is equal to cosine of negative pi over 4. We did this when we were looking at inverse trig functions. We did that as well. On the contrary, if I had sine of negative pi over 3, that would be negative sine of pi over 3. And hopefully you can think about why that is. Well, sine of negative pi over 3 is down here. Sine of pi over 3 is up here. Well, sine of pi over 3 will be positive. Sine of negative pi over 3 will be negative. On the flip side, cosine in both of these quadrants will end up being positive because you're going to the right. So again, you won't see them or use them a lot. You'll use the Pythagorean ones a lot more, but it is something to just be familiarized with in case you see that. So as we kind of work through these, I'm going to just maybe do a couple of these just to get yourself familiar with this. Okay, so let's start with B. We want to prove that this equals tangent of x. And sometimes they'll give that to you and ask you to prove it, and sometimes it might be like which one is equivalent. So a good strategy is to kind of rewrite in terms of sine and cosine. So I know that secant is 1 over cosine of x. If I multiply, I get sine of x over cosine of x, which equals tangent of x. And so I've now shown that it equals the right side. Let's do one that's maybe a little bit more complicated. Let's do this one down here. Again, a good strategy is to rewrite in terms of sine and cosine. So secant squared would be 1 over cosine squared. And then tangent would be sine over cosine. All right, well, once I get to this point, I see a fraction divided by a fraction. So I'm thinking keep, change, flip, multiply by the reciprocal. So I'm going to do this times cosine of x over sine of x. Well, I can cancel one of my cosines. That's fine, okay? And I'm left with 1 over cosine of x times, that's canceled, 1 over sine of x. And maybe you can see, hey, wait a second. 1 over cosine of x, we know is secant of x. And 1 over sine of x, we know is cosecant of x. So therefore, I've shown that. Okay. All right, let's see. Let's look at the back. Let's look at one that involves a little bit more. Okay, number 6. All right, we want to verify this identity. So I don't want to touch the right side at all, but a good strategy on a lot of ones like these is if you can multiply, if you remember when we dealt with conjugates like a plus bi, if you multiplied by a minus bi, you'd get a lot of cancellation there. So on this one, where I see 1 plus sine of theta, I want to think about, can I multiply by the opposite of that, which is 1 minus sine of theta? Okay, and you'll see why in just a second. So cosine of theta times 1 minus sine of theta. Again, I'm not touching the right side. I'm just going to show that it equals that at the end. And then I need to multiply these two things. So let's make a little box. 1 plus sine theta, 1 minus sine theta. Gives me 1. Positive sine of theta, negative sine of theta, negative sine squared of theta. So I end up getting 1 minus sine squared of theta, because the sine and the negative sign would cancel out. Okay, well, this is where we have to kind of reach back into those Pythagorean identities we just did. So we said sine squared of x plus cosine squared of x equals 1. Well, this is just an equation, so I can manipulate it just like I do normal equations. If I subtracted sine squared of x on both sides, I would get cosine squared of x equals 1 minus sine squared of x. My whole goal is to have some cosine in the denominator, so that's why I'm thinking about, can I rewrite this denominator as some function of cosine? And hopefully you can see now, while I have a cosine on top, I have a cosine squared on the bottom. So I can cancel one of those and I get 1 minus sine of theta over cosine of theta, which is exactly what I wanted to show. So these will take a lot of practice. I'm going to give you some extra practice on these as well, because it does take a lot of making sure that you're familiar with all these things. But once you get the hang of it, they're kind of fun. Well, maybe you don't think so, but I think so. All right, next are sum and difference and double angle formulas. So sum and difference, these are ones that you do have to memorize again. So I'm going to show you kind of some tips and tricks to how to memorize these. So how I think about this is sine. If you're adding two angles, this is always going to be the exact same sign. So sine is the same. If I'm subtracting two angles, well, then that sign will be the same. It'll be negative, negative. Cosine, on the other hand, will be opposite. So if I'm adding two angles, I'm going to subtract, and if I'm subtracting, I'm going to add. Then you'll notice it goes sine, cosine, cosine, sine, and the cosine one goes cosine, cosine, sine, sine. And the reason we want to be able to do this is because if I have something like sine of pi over 3 plus pi over 4, I can't just break that up. That's not equal to sine of pi over 3 plus sine of pi over 4. You can't break it up like that. You have to use these formulas. So this will allow us, by using these formulas, to find angles that are not exactly on the unit circle, but maybe are a sum of two angles on the unit circle, or a difference of two angles on the unit circle. So same idea with double angles. So if I have something like pi over, I'm trying to think of one that's not on the unit circle, but the double angle is, well, let me do like 15 degrees. Let's just do degrees because that's easier to think of. So if I take 15 degrees, I'm not going to be able to find that, but if I double that, then I would have 30, and that would be something that I am able to find. Okay, a little bit weird to think about, and a lot of times there's actually half angle identities, which we would use to find something like this that we don't know, but you're not responsible for knowing those. Okay. All right, and then the next one, cosine, notice has three different options here. So if I see my three different options, I see this, this, and this. I would just memorize the first one. You can get the second two by memorizing the first one. All right, remember that cosine squared, this is what we did on the previous page, of u would be the same as 1 minus sine squared of u. Alternatively, sine squared of u would be the same as 1 minus cosine squared of u. So if I wanted to take this and rewrite it as 1 minus sine squared of u minus sine squared of u, I would get 1 minus 2 sine squared of u. Alternatively, if I took cosine squared of u minus 1 minus cosine squared of u, double negative ends up positive, and I get 2 cosine squared of u minus 1, which is this one right here. So there's many different options on this one, but if you just memorize the first one, then you'll be good to go. All right, so let's look at what these actually look like. This is an example, 5 pi over 12. That's not on the unit circle. So previous to this, you would not be able to find what it is. But we can break that up, and it tells you to break it up into pi over 6 plus pi over 4. And just a quick reminder, pi over 6 would be like 2 pi over 12, and pi over 4 would be 3 pi over 12. And so that's how I end up getting 5 pi over 12. Okay? All right, so I could rewrite sine of 5 pi over 12 as sine of pi over 6 plus pi over 4. Okay, essentially this is my A and this is my B. Okay, or alpha and beta, how they use up here. So I'm going to use my formula and I'm going to say sine of pi over 6 cosine of pi over 4. Again, sine A cosine B. Because I'm adding, sine is the same, so that will also be adding in here. Cosine of pi over 6, sine of pi over 4. You should always have both of them in your equation. So if you're stuck and you're like, is this supposed to be cosine or sine? I already did a cosine of pi over 4, so this one has to be a cosine of pi over 6, if that kind of makes sense in your brain. All right, from here it just becomes doing my unit circle. So sine of pi over 6 is 1/2. Cosine of pi over 4 is root 2 over 2. Notice how quickly I'm doing this. That's probably because you need to know your unit circle. Cosine of pi over 6 is square root 3 over 2. Sine of pi over 4 is square root 2 over 2. There's not a lot of simplification that can be done, but there's a little bit. So for this first one, when I multiply those together, I get square root of 2 over 4. For this next one, you can multiply inside the square root, so I get square root of 6 over 4. And I'm just going to combine that into one fraction, but notice I'm not adding. You cannot add those two together. That's the only thing you can do. All right, I'm going to do one more of these, and then I'll leave the practice with the double angles. I'll leave that for the next video. Okay, so another sum, 7 pi over 12 is equal to, essentially that's 3 pi over 12 plus 4 pi over 12. So remember my formula for cosine is cosine A, cosine B, not cob, cosine B. And then because I'm adding, cosine is opposite, so minus sine A, sine B. I'm going to plug into my formula, cosine pi over 4, cosine pi over 3. And it doesn't matter if I were to switch the order of these, your formula at first would look different, but you're multiplying, so it's not going to change it. So don't stress about that. Again, I'll do examples on the double angle stuff in the next video, so we're mainly just focusing on rewriting trig expressions and sum and difference. So cosine of pi over 4 is root 2 over 2. Cosine of pi over 3 is 1/2. Minus sine of pi over 4 is root 2 over 2. Sine of pi over 3 is square root of 3 over 2. Again, some minor simplification can be done. Square root of 2 over 4 minus square root of 6 over 4. And then I'm just going to rewrite them with a common denominator. Notice that these look very, very similar because they're both dealing with pi over 4 and pi over 6. A lot of times you'll get some variation of that, whether it's positive, whether it's negative, which one goes in the front or the back, but it usually is some variation of that because you're using the same unit circle angles. All right, so big idea is making sure that we can rewrite trig expressions as equivalent ones. These identities are super, super, super important. But remember, you're not trying to memorize every single one. You can derive the other two by knowing the first one. And then your sine, the sign is the same when you're adding. Cosine is opposite, and making sure that you know how to use these. Again, double angle, we will go through examples in the next video, so don't worry about that quite yet. Have a great rest of your day.